All right, let's get going into our new stuff here. So this is where we're all trying to get to, balancing molecular equations. We're trying to get to the down here part, where these are super challenging, but we've already gotten most of the way there. So this is what we're trying to look for. Pretty much like the acetic method, but then a sum. So pretty much the acetic way, electrons, 2 half reactions into 1. Then, depending on the actual equation, you want to start getting rid of these other things and adding equal amounts of elements to the final equation to make it look like the final equation. So what's really interesting about this is you're not really balancing too much of the numbers by this time. You're trying to balance out the actual compounds themselves. So here's our first example. So here would be our normal formula equation and our the 2 half reactions. After balancing this one acidic wise, you would come to this part here. So we need to translate this into what's above. And essentially the numbers are going to pretty much stay the same. Let's take a look at that. Alright, so I can see if I want to get rid of the H's, I have the first thing that has an H, and then HCl over here. I don't even see Cl over here, but I can also see it's not present on the right side as well, so I'll be adding it to both sides. So first off, because I have 3 of these C2O4s, that's going to take away 6 of my hydrogens. So that's going to make it, I'll need 2 hydrogens for each of these because it has a charge of 2 minus. And so that will give me 10 H pluses, which all need to go to the Cl. So that would be 10, and these are again 1 each. And I'm going to kind of utilize my top and bottom like I have been in the past 2, just to give myself some more room. So what that means is that I've added 10 Cl's to both sides. So I'm going to add, 10 of the Cl's, right, to this side. I'm also going to be looking at this CrO4 part. I can see I need to add some K's. So I'm going to add the needed K's to get there. So that would be 2 of those CrO4. Again, we don't have the charge written there. So if I added 4 K's over here, and I already see I've got Cl's in 2 different spots, right? This is 10 Cl. Well, KCl is going to be something. And if I already have 4 on the left, I'm going to need to have 4 right here. Okay, so that leaves me with just 6 Cl's now. I also have this Cr3+, which goes here, and I have 2 of them. So that means I need 2 Cl3s, and 2 times 3 is 6. So these ions are now bonded into this. Okay, they're already bonded. So I look at what I've got left, right? The HCl is present. The H2C2O4 is present. The K2CrO4 is present. I've translated this Cr into CrCl3, good. KCl, present. And then I just have CO2 and H2O. So really, I just need to add those into my final. 8 H2Os. And from here, I should be good. I just double check my stuff. And that's where I'm at. So you can double check the numbers if you want to quickly. Obviously, it takes some time because there's so much there. But this is what we're taking it for. This is why we learned to get to here in the first place. Because after that, it's kind of like matching up the formulas will then help you determine what these numbers are. And you can see I didn't really change the numbers. This was still 3, this was still 2, this was still 2, these were 6 and 8. I had to kind of develop the ones that were missing, but essentially all of what I've already balanced is already done. Let's take a look at one more example and then call it a day. Alright, so we got another problem here. We've got this all laid out, got our reactions, we would have gone through the process. I could see this was done acidically because I got this. And again, that's going to be your most likely approach. Now I want to look at how do I add things together. So first off, I can pick pretty much any of these. I can start pairing the hydrogens together because I can start seeing that I'm going to need, in order to make this H2SO3, I'm going to need 10 hydrogens because I'm going to have 5 H2SO3. However, to get 10 hydrogens, I only have the 6, so I'm going to add another 4. And remember, you got to do that to both sides. We'll see how that will become handy in a little bit. So this will take care of my 10 here. And I don't have hydrogen any other place. Over on this other side here, right, with this KMnO4, I've got a 2 here. And because that has a charge of -1, MnO4, I'll need to have 2 potassium on the other side as well, which, looking at my K2SO4, is going to be somewhat of an interesting case here. So in looking at this, I have SO4 in 3 different places, so I need to separate out what I've got on this right-hand side. So I can take a couple thoughts of this. I can look at the manganese, right, MnSO4, and I've already got a coefficient there, so 2 MnSO4s. So because there's a 2, this 5 now becomes 3 available. Okay, so I took care of that one. I also see I have 2 potassium on the left, so I'm going to need to have 2 on the right, and 2 potassium are going to take 1 SO4. So now I've balanced out my potassium, and that's going to take off 1 SO4. So now I'm down to 2. I've also got these H pluses I need to deal with. And I see for every 1 SO4, I need 2 hydrogens. That's good, because I have a 2-to-1 ratio. That means this can be H2SO4. And I already have my coefficient here of 2, based off of the SO4 ion. And then I've got my water left over. So I've got now all of these put out to where I've got my 2 H2SO4, my 3 waters, my potassium sulfate here, and my manganese sulfate, a whole bunch of stuff on that side, and only 2 on the left. So you can see that this is quite a different process than the other one, but you're still approaching it the same. Sometimes you need to split things up, like the hydrogens and the sulfates, to distribute them, but you're going to be provided the idea of the formula equation. You'll need to come up with a net ionic, that's still on you, but we'll give you the half reaction so you can get there. All right, come in with some questions, and I'll hope to see you soon. Take care.